Hello, my name is Nick Mowry, and in this video I'll be talking a little bit about real-time kinematics. Now this is more of an application in terms of applying a technology to a program as opposed to a ready-made digital application. My interest in using this approach is to develop a system which imparts some level of automation for precision agriculture. I use this term loosely since my test bed for this method will look a little more like lawn care than farming. But that said, I plan to adapt an open source automated lawnmower to work with accurate GNSS data rather than reacting to physical barriers or hidden fencing. Along with one or more drones capable of sharing the locations of weeds, a mower will be equipped with herbicide and could target these locations and spray them during normal mowing operations. But the whole thing relies on accurate placement of the mowers and the drones to coordinate between themselves. Now, while this scenario is very specific, I see this route as viable for the freelancer and corporate types alike. For someone with a decent GIS background, a penchant for programming, and a few $100s, this device removes the high-end cost hurdle of commercially available products. Even if you work for a public or private entity, this approach to accurate GIS data could turn a relatively low-budget request into a massive cost savings, profits, or just massive amounts of data. Now, assuming an unobstructed view of the sky, GPS is only so accurate. Even if you're tapping into multiple frequencies and satellites, the best you can generally hope for is accuracy within a couple of meters. The forthcoming L5 band might bring that range as low as a foot, and for most applications that's okay, but if you're talking about robust locating data for something like surveying or precision agriculture, a foot just isn't going to cut it. Now, real-time kinematics lets us determine the difference between where something actually is and where GNSS data tells us it is. Now, by applying this correction vector to nearby points, Gnss-Rtk allows for accuracy down to the centimeter range. Now, there's many U.S. locations that are taking advantage of this accuracy, and by searching the ngs.noaa.gov website, you can find these towers potentially local to yourself, and some of their historical data is also posted there. You can use this historical data to post-process some of your collected data. It's not all of them are available real time. However, if you're fortunate to be within 20 miles or so of one of these towers that is providing real-time data, you can request access from UNAVCO for this data. If not, you can use one of these U-Blocks devices to create your own base station. So at the heart of this approach is the U-Blocks ZP9F chip, here pictured top center in red. Now this is installed on a dev board produced and sold by SparkFun. It collects its own GNSS data, and when supplied with a steady stream of RTCM correction data, the unit outputs corrected data at up to 20 Hz. This data can be back-channeled to any device capable of using it. So the dev board and the libraries required to program this board are open source and well supported. The example programs provided by SparkFun cover all the device's features, are well commented, and can be easily adapted to your unique application. There are several free software options for post-processing these data, so even if you don't need them in real time, you can still benefit from the increased accuracy. So let's add up the cost. This board costs about $220. To supply it with RTCM data, you could purchase a Bluetooth board and a battery and use a cell phone for both a connection to the base station and for data logging. Now, this would bring you roughly to $300. Without access to an existing RTCM data stream, you can actually use one of these boards to create your own base station, roughly doubling your cost. So for about $600, you could basically go anywhere and get accuracy down to a centimeter. I'd love to know if anyone else in class has done anything like this. If anyone else is interested in this kind of thing, I'd welcome any questions or suggestions. Thank you for your time.